Good evening everyone.
Hey friends, Matt Pat here, back from retirement. I'm
Good afternoon, good evening everyone. As a part of this course, Advanced Chemical Thermodynamics and Kinetics, this is the fifth session where I will take the questions on vibrational spectroscopy. This is extremely important for CSI NetCat. This is the session 5, 24 to 2025. Hopefully, previous sessions are good and helpful to you for learning the course and learning the study material. So this is the first question where you need to find the energy of vibration level in terms of angular frequency. So we know that E equal to mu plus half h mu. So this v mu is the quantum term, is a vibrational number which can takes the value 0 1 and any particular integral digit. And so this is the energy between the vibration level of v equal to 4. So if you just put the value of 4, so your is going 4 plus 1 by 2, this is basically 9 by 2, so which is coming around 4.5. And this value is very much common, that h h cross omega. So h cross is nothing h by 2 by into omega. So it is already given to you angular frequency in terms of angular frequency. So you can do that IH by 25. So H is 6.626 into minus 34 joule per second. So if you do this 6.626 by 2 into 10 to the power minus 2 by 3.14, so you will get the value of 1.055 into 10 to the power minus 34. 1.055 minus 34, and from there you can get the value 4.24, 4.75 into minus 34 omega joule. So this is the value. So if you see in all of the cases, so it's coming to the point B. So B is the final answer here. So in this question, basically what you are getting, B will be the final answer, right? So here answer will be B, right? you go to the other one, if you go to the other one, so what you will get is that, so which of the following is an incorrect statement? So photochemical reactions are usually caused by absorption of ultraviolet only. When a molecule or atom in the ground state H0 will absorb light, one electron is excited to a higher orbital level. The excited state S1 can undergo spin inversion, the first step in photochemistry excited state. So what is the incorrect statement? Option A is incorrect. Because the energy for the photochemical reaction depends on the energy of the bond. So this bond can be breaked in UV light visible as well as this IR light as well. So 100 to 400 nanometer is the UV light, and visible light is 400 to 750 nanometer, whereas IR light is 750 to 2500 nanometer. So the first statement, that is this option A, this is the incorrect statement, because the to do this photochemical reaction you need to break the bond, and bond depends on the value of like vibrational frequency, and it can vary from UV visible as well as this IR light. So based on that we can get the value of this one, that is called the, now I will go to a fact that, so in this case if you see this energy diagram, that is called the, sorry, just a minute. So if you see that the, which is the incorrect statement, photochemical reaction, to do photochemical reaction you need to break the bond, and that energy may be equivalent to UV as well as visible as well as your light of this ultra, what is called this IR. So depending on the bond energy you need, you can change the value of this your IR. Now if you see, I would like to take you towards, so so this is the, like, if you try to break up one bond, so what will happen to this, right? So if you try to break up a bond, you need to give UV light, maybe visible as well as maybe other light, that is called the light of around, UV light, visible light as well as this called as, so you need to keep this multiple value of the light, and the bond depends on the how much energy you are giving. So here are the four options. So this kind of question is also there in your previous assignment, where you can see that you can, to get the understand about this fact, you need to get the concept called Frank Condon principle. So just a minute, let me show you one thing. just to simply Google it. Okay, now what I will do, if you simply Google it, so now I will take you so out of these three, so A will be the answer. Now if you go to the next question, where you need to, which of the following is not correct about fluorescence emission. So how fluorescence comes? So fluorescence comes basically this your S1 state to S0 state, where phosphorescence come from T1 to S0 state. So if you see fluorescence emission, so that depends on the many factors. So your basically your emission or your emitted light, emitted, what I'd say, emitted H nu, the light has to come from S0, S1 to S1 to your this state. So what did they say? So fluorescence emission is a Stokes shift with respect to absorption spectrum. Is it so? Yes. It has to be Stokes shift. So it's faster than phosphorescence. That's true, because single transition is feasible compared to this. Fluorescence emission is faster than 5% relaxation. Is it so? No, because the molecule has to go to excited state, then each excited state, excited electronic state is made of some vibrational level, and in vibrational you have the rotational levels. Okay. So fluorescence is maximum for the lowest vibrational state of the excited square. Yes, that's true. Because from S1, if you excite the molecule, it can go to S1, S2, S3, something like this. But fluorescence is considered from S1 to S0 always. Okay. So here, this is the correct answer, right? Just one thing. So remember always, So now if you take the another one, so let's say you have this sample. So this is the so this is the basically you are dividing a dimer and followed by you have this two dimers. Now you are doing this chain branching chain propagation reaction. So your G is given, F in W all are given. So G equal to K4 plus K5. So now major portion is from here in the process. So this is very simple. So you know this G is K4 this one. Now these are the state of the same is referred to as process, whereas between different spin values is referred phosphorescence. So the wrong state of phosphorescence is phosphorus electron. That's true. This is not a wrong statement. So it has a higher level there, right? And that I have already mentioned in your previous skill that Stokes it is probably less than phosphorescence lifetime. Now phosphorescence which has a shorter wavelength than fluorescence. Yes, phosphorescence is the dimensionless emission of a photon, directionless. So higher wavelength. So what is the wrong statement here? Phosphorescence is the directionless emission of a photon. That's law. That's true. So that's true. Phosphorescence usually have a shorter wavelength. No, that's wrong. C is the wrong answer, right? Okay. So here answer will be C.